Good evening, everyone. Okay. So now let's come to our next chapter, chapter number 17, file foundations. Chapter number 17, file foundations. Okay. So now, in the case of the file foundations, okay. So for the file foundations, what is mean by pile foundation? First thing first, in the previous classes we discussed about various type of foundations, shallow foundations and deep foundations. In deep foundation, one of the type is pile foundation. So first thing first, when do we go for the pile foundation? When do we go for the pile foundation? When the load coming from the structure is very high. Even we discussed one question in the previous chapter. So if you do remember, that's one of the previous gate question. Yes, I hope you remember this question, where I gave you 4 columns which are going to be having a load of 4,000 each, and we want to construct in 10 by 10 plan area. So I showed you whether we can go for the isolated or raft or pile, yes or no. See here, whatever the load which is nothing but 4,000 kilonewtons, that's a heavy load. The load coming from the structure is very high, so it cannot accommodate isolated footing, not even the raft also. So which means, see, when I know how much load is coming from the structure, point number 1, when you know what is the bearing capacity of the soil, point number 2, you see here I know what is the load coming from the structure, 4,000 kilonewtons, and I know what is the bearing capacity, 100. Once I know the total load coming from the structure and the bearing capacity of the soil, then I can check whether that load can be accommodated by means of isolated first. First, I'll check with isolated. Okay. So once isolated is not able to take that load, then I go for the raft foundation. So for the shallow, the starting is isolated, extreme is raft. Extreme is raft. Now for the total load, if I provide total area, then still the pressure coming on the soil is 160, but the allowable bearing pressure is only 100, right? So which means if I do construct a raft, the raft is going to be transfer more pressure. So raft is not also going to be possible. Then we go for the pile foundation. Sir, why we go for the pile foundation, sir? In the case of the pile foundation, the bearing capacity is not is equals to 100. Why? Because in the starting of the pile foundations itself, I mentioned you a point. You see, what is that point? Pile foundations has a more load carrying capacity. See, once we got to know if the rafts are not able to transfer the load safely to the soil, then we got to know the load coming from the structure is very high. So the other option is I have to go for the pile foundation. What is the advantage of the pile foundation? The advantage of the pile foundation is it has more load carrying capacity. The raft cannot take that much load safely to the soil, but pile can take. Why? Because when you apply load, listen to me carefully. This is a pile, right? When I apply load, you see, when I apply load, the pile will push vertically downward. Yes or no? When I apply load, the pile will push vertically downward. But while it is pushing downward, now between pile and soil, the shear or friction will develop. So when you apply vertical load, the pile will pushes vertically downward. And in order to resist this, then the soil will offer a resistance, a frictional resistance upward. which is nothing but skin friction. So due to this skin friction, pile has more load carrying capacity. These points all I have discussed here. Now let's see in simple point now. First we check with raft. If the raft is not able to transfer the load safely, then you go for pile foundation. Sir, in the case of the, in the case of the well foundations also there's no. So when do I go for the well foundation? Generally, we go for the well foundations. If I want to construct a bridge piers, so water bearing stratas. So in the case of riverbed, we go for well foundations there, not the pile foundations. So basically, the necessity of the pile foundation is to resist heavily loaded structures on relatively loose soils. To resist heavily loaded structures on relatively loose soils. On relatively loose soils. Okay, so that's the necessity. Now, how we are going to design the piles? Just like in the case of the shallow foundations, we know what is the pressure acting on the footing, and based on that we design what is the width of the footing, depth of the footing, all those things, and how much load that the shallow foundation can take. Yes, how much load? In the case of the design of a shallow foundation, whatever the gross pressure taken by the footing should be less than or equals to safe bearing capacity. So this all we discussed in the previous chapter. Now, in the case of the piles, before you design, we have to classify the piles. We use piles for various functions. Classification of piles. So we do classify the piles based on the various functions. Number one, based on function. Based on material we use. Based on method of installation. Based on displacement, and finally based on load transfer. This is very, very important for us. So this point is very, very important because eventually as an engineer, we need to classify the pile based on how the load is transferred to the soil. So eventually our main object is to transfer the load safely to the soil. Yes. So let's see one by one. First, based on installation. Sorry. Based on function. Based on function. Okay. So how we are going to discuss this based on the function. So based on function, there are various type of piles. Number one, compaction pile. Number one, compaction pile. So what is the meaning of this compaction pile, sir? The first function, functionality means it's a significance. See, in the case of the, listen to me carefully, in the case of the, if this is a granular soil, which is a loose granular soil, loose sand, let's take, it's a loose sand, okay. Say, if the loose sand, if the soil is loose up to a shallow depth, if the soil is going to be loose up to a shallow depth, up to small depth, I can densify it by means of shallow compaction. You remember that by means of the rollers, by means of the vibrators, smooth wheel rollers, I can do that. So if the soil, especially sand or granular soil, if the soil is loose in shallow area or shallow depth, I can compact it by means of compactors like a smooth wheel roller or vibratory rollers. But what if the soil is loose? What if the soil is loose to a greater depth? If the soil is loose to a greater depth, I cannot go for the whom shallow compaction. Then what I'll do is I provide a borehole or I dig a borehole. Sir, how you are going to digging a borehole, sir? By using a borings. Augers would be there, or wash borings would be there. So there are different type of different ways to dig a borehole that we'll explain in soil exploration chapter. So what I do is I'll dig a borehole. And now I will pour a highly graded material like gravel. I'll pour a highly graded material like gravel. You see, what I'm doing is I dig a borehole, I remove the loose sand. Now I am adding the gravel and I'm not going to stop there. What I do is I'll compact it. So you see, once after digging the borehole, we added a highly graded material, then we start compacting. When you start compacting, due to this, the surrounding soil also gets compacted or not? Due to this, the surrounding soil also gets compacted. Yes or no? And as you go for the graded soils and again you are going to compact, then due to this, the surrounding soils will get compact and compact and compact. Eventually, the soil, the loose sand will get densified. We call this one as a stone column. What we call stone column or compaction piles. So the first function of the first function means the type of the pile based on the function is compaction pile. So this compaction pile is to densify the loose granular soils. Okay, so that's nothing but the compaction pile. Now, second one, anchor pile. What is mean by anchor pile, sir? This is a sub part of the pile, actually to say. This is a sub part of the pile. So what is mean by anchor pile? So if you observe the anchored pile, okay, let me take the figures. Okay, so everybody, you please observe. You see this one. You forget about the remaining things. You see, first of all, what is mean by sheet pile over here? You please observe the purpose of the sheet pile is to retain soil. Just like we discussed about, in the case of the retaining walls. So the purpose of the sheet pile is to retain soil. Okay. Now, if you observe carefully, if you understand here, so you see, I am providing some anchor over here, and I am telling you this pile is nothing but an anchor pile. Yes, I am telling you this pile is nothing but an anchor pile. In fact, to say, I am providing an extension rod to this pile. Why? Because now you see. Now you please observe. When the wall tries to move or away, when the wall tries to move away from the backfill, it will create a active case. When the wall moves towards the backfill, it will create a passive case. Now, in order to provide anchorage, from the movement of the wall, so I don't want to move either away or I don't want the pile to move towards. So listen to me carefully. When the wall is moving away from the backfill, I am providing an anchorage. When the wall is moving away from the backfill, I am providing an anchorage. And this anchorage will try to keep the wall in position. Such type of pile is known as an anchor pile. Such type of pile is known as an anchor pile. So what is by anchor pile? To provide anchorage against horizontal pull from sheet pile or retaining walls. So what is mean by sheet pile? The sheet pile is nothing but simply to support or to retain this soil mass. And when this pile wants to move away, I am going to provide an anchorage so that this total pile will be in position. So that means, so when the wall tries to move horizontal pull, then it provides an anchorage. That is known as anchored pile. And next, third one, uplift or tension piles. Third one, tension piles. So what is meant by these tension piles? This tension piles is to resist the structure from uplift. So when do we go for the tension piles, sir? So generally we go for the tension piles when we try to resist the structure from the uplift. Sir, how does it happen, sir? You see, in the case of the transmission towers, now let me show you that. You observe here. So what is going to be happen? See, in the case of the multi-story building, or in the case of the transmission tower, this is nothing but transmission tower. Or in the case of the transmission, this is a transmission tower line. And in the case of any structure which is having a basement floor, this is going to be the basement floor, right? Yes. So now if you observe, what I am going to say in this case over here is, in all the three cases, when there is a overturning, so due to overturning of this structure, listen to me carefully. So when this structure gets overturned, which means when the structure tries to tilt in one direction, you please observe here also. When the structure gets overturned, now you see, when the structure is trying to overturn on one side, the structure tries to lift up. Yes or no? So when the total structure is about to overturn, on one side the structure will lift up from the soil. You see, the structure will lift up from the soil. This is nothing but uplift. And once the uplift is going to be happening, now this pile will tries to resist the uplift. So whatever the pile, you see, once the structure is about to overturn, the structure overturns by lifting up, uplift force, and this pile will make it down, means whatever the pile that I should construct, that should resist the uplift. And what is this action? Does this action looks like a tension or not? Yes. So due to overturning, it will create a tension in the pile. That's the reason why we call it as a tension pile. So generally we do observe in the we do observe in the case of the heavily constructed multi-story buildings or transmission towers. So the tension piles are to resist the structure from uplift. Tension develops in pile due to overturning. Next, batter are raked or raking piles. piles. So the batter or raking piles is simply, the batter or raking piles are simply to resist the large lateral forces. To resist the large lateral forces. So whether means either by means of wind, either by means of wind or water. So to resist the large lateral forces. To resist large lateral forces, we go for the batter or ranking piles. See, these piles are nothing but inclined piles, my dear. You please observe. Here I have observed. This is not batter, this is batter pile. This is a batter pile. The batter piles are inclined piles. These are nothing but the inclined piles. Batter piles are nothing but the inclined piles to resist the structure from uplift. To resist the structure from uplift. Okay. So, and last one, fender or dolphin piles. Actually, these we construct in the front end of waterfront structures. These we are going to construct the front end of the water. These we are going to construct the front end of the water. So in tension piles are made of concrete or different materials. It can be that we'll see. Okay. Fender or dolphin piles. These are to resist impact from ships. You please observe here, whatever this pile, this is nothing but fender pile. UK. Okay. So if you observe, when a ship is going to be about to come, in childhood we do try to do this type of ships, right, with paper. Okay, when the ship is going to become, when the ship comes, it gives impact to the harbor area. So whatever that impact will be taken by the fender or dolphin piles. So these are the various type of piles. Every pile is included in this figure you see. Every pile you can see in this figure. Except uplift piles, because this is there is no uplift over here. Okay, for the uplift I have shown you in this figure. For the uplift, so these are nothing but uplift or tension piles. Okay, so whenever the ships are going to be about to enter the harbor area, and next to that there are piles. Sir, should we provide these all piles for one structure? Yes, actually we do provide in the case of the harbor areas. We do provide all this in the harbor areas. It depends upon the situation. If there is a site near river bed, which foundation we prefer? So if it is near to the river bed, then we go for pile foundation. But if you are doing in river, in water bodies, then we go for the well. Now, if you do observe, so whatever the pile, you see, this is nothing but inclined piles, right? These inclined piles are resisting the, see, these inclined piles are resisting the structure bridge. So whatever, this is nothing but a batter or raked piles. Okay. So what is the cause of uplift upward seepage? No, sir. No, it need not be every time uplift. Due to, you see, you can observe the wind loads. Na? You please observe, there is a wind loads, right? Due to the wind loads for high-rise buildings, if you don't consider the wind loads or earthquake loads, if you don't consider the wind loads or earthquake loads, then the entire structure may get overturned. Okay. All are piles only, but based on, see, all are piles only, but based on the function, you have to define that. Based on the function, you have to define that. Okay. So now I hope you understood. So what are the various type of piles based on the function? You just need to know. So these piles, you can get it as MSQ, multiple select questions. MSQ would be there. Okay. So now let's see the next part. So first one we discussed about based on the material, and second one based on your function, and second one based on the material. Just go away. Based on material. So see, we can construct the piles by means of various materials. You can see these are the various materials that we can take. We can go for the directly concrete pile, or we can go for the steel pile, we can go for the timber pile, we can use I sections, or we can use a precast concrete piles, and we can use composite. Composite is simply a precast plus steel. So these are the different type of piles that we can use based on the material. Now you might be wondered, sir, how we are going to drive the pile, or how we are going to install the pile. So there are various ways to install the pile based on installation. So number one, precast driven pile. What is the meaning of precast driven pile? Precast driven pile means, cast means preparation. Precast means I prepared the pile already in the field. I means already in factory. I prepared the pile already in the factory. And then what I do is I take that pile and I'll bring that pile into the field by means of the crane. Let's see how it is going to be looks like. Yeah. So if you observe here, so I have already prepared a pile. This is either a timber pile or a concrete pile or a steel pile or any pile you take. Already I prepared the pile. Already I prepared the pile in factory and I bring that pile into the site. So by means of the heavy cranes or heavy hydraulic machines, I lift up the pile and I keep in position. I keep it in a position. So we keep that on a position, and then by means of this one, by means of pile driving equipment, I am going to hit it so that this pile will drive into the soil. So here, based on the installation, number one, precast driven pile. So whether it is whatever the type of pile, concrete, steel, or timber pile, prepared in factory, erected in position, prepared in factory, are driven into soil by erecting the pile in position using pile driving equipment. using pile driving equipment. So by using the pile driving equipment, I am going to erect, by using the crane and all those things. So I will erect in the position and I'll simply drive it. There is nothing. Simply we just drive it by applying a hammer. Means a dynamic action. Dynamic action would be there. While driving equipment. Okay. So this is a precast driven pile. That's nothing but the precast driven pile. Sorry if it breaks but while hitting. Baba, you have to. Very good question. So you have to apply that load in such a way it shouldn't break the pile. And in this, the second one is cast in situ driven pile. So what is mean by cast in situ driven pile, sir? The cast in situ driven pile, now precast I made in factory. Cast in situ means in the field. So I am going to prepare the pile in the field by driving. How, sir? Now a hollow steel tube with horseshoe. Horseshoe means cutting edge. With horseshoe, which means cutting edge. At the bottom is driven into soil. So now what I do is instead of the pile preparing, I take a hollow steel pipe or a tube which is having a cutting edge at the bottom. Why cutting edges, sir? When I am going to drive it at the bottom, due to the sharp edges, the pile will penetrate into the soil. Say a hollow steel tube with a horseshoe at the bottom is driven into the soil. And whatever the soil inside of the pipe, we remove it. Later, filled with concrete. Later, we simply filled with the concrete. So first we drive a hollow steel tube and then we are going to fill it with the concrete. So timber won't decompose or decay. See, that's what I am saying. See, why? Okay. See, if you observe, based upon the load that we are going to imply, you have to decide. Okay, if the load coming from is not that too much, then I can go for the timber. See, the timber is a wood. Would have some properties that you already know from the strength of materials. So wood properties, there are a lot of factors would be affecting temperature. Temperature would be there, moisture would be there, lots and lots of factors would be affecting. Now my point is not about discussing those factors. My point is to make you what are the type of installations. Okay, and there comes the third one. Bored cast in situ piles, or simply we call it as bored pile. Simply we call it as bored piles. Sir, how these are going to be prepared? In the case of cast in situ, I driven a hollow steel tube. Here I am not going to drive anything. What simply I do is I am going to dig a borehole. Please observe here. I am going to dig a borehole by using the borings. So by using the borings, or let's say auger boring. So I am going to dig a borehole. I'm going to dig a borehole. Then I am going to provide the steel. Then I am going to fill the concrete. Okay. So this is a concrete and this is nothing but steel. So what we are doing in the case of the bored piles is, we dig the borehole by using the borings. We dig the borehole. I mean, yes, we have to provide the reinforcement. So we dig the borehole in the soil, and then we later filled with steel and concrete. Boreholes are dug using borings, later got filled with steel and concrete. Sir, out of these, which one is going to be more efficient? Which one is going to be more efficient? That depends upon various factors. That depends upon what load you are going to take. That depends upon how the load is going to be transferred. And now let's see how that load is going to be transferred. So I told you first one is based on the based on the function, based on material, based on installation, and based on displacement. We'll see that last based on load transfer. Based on load transfer. And this is very important for our examination. So how the load is going to be gets transferred. So based on load transfer, we have three different type of piles. We have three different type of piles. One is an end bearing pile, other one is a friction pile, and the third one is going to be combined pile or composite pile. Okay, so first one. Now Bro, are you from Kurkla? Immediately there is a chat section open. Okay, fine. Yes. So we were discussing about this, right? Yeah. So based on the load transfer, how we are going to transfer the load? We have end bearing or point bearing pile. First thing first, end bearing or point bearing piles. Okay. So what is this end bearing or point bearing piles? What is this end bearing or point bearing piles? See, whatever the pile that we are going to construct, let's take that pile. So this is a pile. Okay. So let's take this is a pile. Okay. For example, if this pile is resting on a hard strata, so now let's take this is a ground level. Whatever, this is nothing but the ground level. For example, if this pile is resting on a hard strata, or if a hard strata is located at reasonable depth, if hard strata is located at a reasonable depth. So now you see, let's say there is a hard strata. Let's say there is a hard strata. So now, if you observe, whatever the load that I apply, if I say this is nothing but a hard strata, whatever the load that I apply, that will be taken by whom? Pile. Whatever the load that I apply, that will be taken by whom? Pile. The load that I apply will be taken by the pile. And if this pile is resting on a hard strata, which is located at a reasonable depth, now the entire resistance of this pile depends upon the point or end bearing resistance. Point or end bearing resistance from the soil at the pile tip. Okay. So in simple words, if hard strata is located at reasonable depth, if the hard strata is located at a reasonable depth, the maximum load that the pile can take, the maximum load that the pile can take entirely depends upon the resistance from the end or bearing. So unit resistance from the end bearing. And whatever the ultimate load means, maximum load is nothing but ultimate load, right? The maximum load that the pile can take depends upon the unit or point bearing resistance offered by the soil, which is nothing but QB, which is nothing but QB. So if hard strata is located at if hard strata located at reasonable depth, or pile stands on hard strata, the load carrying capacity of pile load carrying capacity of that pile, whatever the pile I am taking, depends on unit point or end bearing resistance. from pile tip of soil at pile tip. Okay. So what is the meaning of pile tip? Pile tip is nothing but bottom. Okay. Now let's see what is the meaning of then friction pile. If you have understood this one, then you can understand the friction pile also. So here I am saying you that if there is a hard strata located at a reasonable depth, that's what I mentioned. Yes. Now what if there is no hard strata, sir? If there is no hard strata, so such a type of piles are known as friction piles. So now if I take the same pile, but this time there is no hard strata, this entire soil is a soft soil. This entire soil is a soft soil. Now when I apply load, what happens is, when I apply load, whatever the load taken by this pile depends upon the skin friction developed between, or frictional resistance developed between the soil and the pile. Depends upon the frictional resistance developed between soil and the pile along its length, which is nothing but QS. And whatever the maximum load that this pile can take. See, here I am neglecting the end bearing because there is no hard strata. So whatever the maximum load that the pile can take depends upon the skin friction resistance between the soil and the pile. So if pile is installed in soft soils, the ultimate load carrying capacity of pile depends on frictional resistance, or I can say skin friction between pile and soil along its length. So whenever we go for the friction piles, in the case of the friction piles, can you tell me what is mean by ultimate QU here? See, I am giving you the meanings also. What is mean by QU? The QU is nothing but ultimate load carrying capacity. So in the case of the end bearing pile, the QU ultimate load carrying capacity depends upon whom? Depends upon bearing capacity, means point bearing capacity. And here ultimate load carrying capacity depends upon the skin friction between the pile and soil. Okay. Now there comes the composite pile. There comes the composite pile. So the composite pile is nothing but a combination of both. You can observe both friction and end bearing. Okay. Third one. Composite are combined piles. Okay. So what is mean by composite or combined piles, sir? Now, if there is a hard strata and a soft soil located, if there is a hard strata and a soft soil located, now if you observe, this is nothing but a hard strata and this is a soft soil. Then when I apply the load, you observe here, when I apply the load Q, initially, listen to me carefully, when a vertical load is applied, the pile will move vertically downward. Initially, friction will develop along the sides. Friction develops between the soil and pile along the sides. Slowly, whatever the friction developed, it will get mobilized, and finally the point bearing resistance is also going to be developed, which means here whatever the maximum load that this pile can take, what is mean by maximum load that the pile can take is nothing but QU, depends upon the what is the maximum skin friction developed and what is the point bearing resistance. So here QU is equals to QB plus QS, where, sir, in end piles, sir, is soft soil only capable of providing frictional resistance? Yes. End bearing piles, no dependency on the skin friction? No. If I say end bearing pile, you neglect the friction. If I say end bearing pile, for end bearing piles, we neglect the friction. For friction piles, we neglect the point bearing resistance. And if they don't mention anything regarding to the pile name, we have to take it as composite or combined piles. We have to take it as composite or combined piles, where QU is ultimate load carrying capacity of pile. QU is nothing but ultimate load carrying capacity of pile. QB, unit end or point bearing resistance. Next, QS, skin frictional resistance. So these are the terms that we are going to see: ultimate load carrying capacity, unit load, unit or end point bearing resistance, and skin friction resistance. If I do say end bearing pile, you neglect the friction, which means QU is equals to QB only. If I do say if it is a friction pile, then you neglect the end bearing, which means QU is equals to QS only. Okay, so now this is based on the load transfer and based on displacement. Based on displacement. You can call it as a displacement piles or non-displacement piles. Displacement piles are nothing but, see, displacement piles are nothing but the driven piles, right? Yes or no? When you are driving, observe, you take a hammer, you give a blow on the earth. You take a hammer and you give a blow on the earth. When you give a blow on the earth, then due to that hammer impact, the surrounding soil also will get disturbed or not? Yes or no? Yes. So in the case of the displacement piles, which is simply known as a driven piles, what happens over here is surrounding soil gets displaced or disturbed. Driven piles. So surrounding soil gets disturbed during installation. Especially the clay soils. Especially clay soils. So what happens in the clay soils is the clay soils gets remolded during installation. Clay soils gets remolded. Whatever the clay soil is there, the clay soil is going to be gets remolded and lost its strength. In the case of the driven piles. In the case of the driven piles, okay. Yeah. Now, second one is non-displacement piles. And these non-displacement piles are simply bored piles, my dear. Because what we are doing in the case of the bored piles, what we do in the bored piles, simply we dig a borehole, that's it. And after digging the borehole, you are going to do your work in the borehole. The surrounding soil will not get disturbed, right? Much. Yes, there is a disturbance, but it won't create too much of disturbance. You cannot say there is no soil disturbance. I'm telling you, you cannot say there is no soil disturbance, but compared to driven piles, in the case of bored piles, the disturbance is very less. So generally, the note point here is, generally for the clayey soils, we go for the bored piles. For the sandy soils, we go for the driven piles. So generally, driven piles are preferred for sands, preferred in sands, and bored piles preferred in clays. So generally, driven piles are preferred in the sands and bored piles preferred in the clays. Why, sir? Now you may ask me, sir, while boring there will be some. Yeah, that's what I am saying, Mr. Tushar. Yes, there will be some disturbance, but that disturbance will not create a remolding directly. Sir, why you are replacing the displacement soils in the case of sand, sir? Arre Baba, you see, in clays it gets remolded, in sands it gets densified. While you are going to drive now, the loose sand, remember the point in shear strength chapter. When loose sand gets sheared, it behaves like a dense sand, which means soil gets densified. So generally, the driven piles we are going to prefer in the case of loose sands, and bored piles we prefer in the case of clays. That doesn't mean that I don't use driven pile in clays. That doesn't mean that I don't use bored pile in sands. I'm saying you generally preference. The preference order is, if it is a sand pile, means if it is a sand, directly I can go for driven. That doesn't mean that I cannot go for bored. You can go for bored also. Okay. So now this is about the classification of various piles based on its function, means based on the function, material, installation, displacement, and load transfer. What we required is this one. Eventually, we need to design, right? The design simply nothing but how much pile is able to take. Yes or no? So that depends upon the capacity of the soil mass. In the previous chapter, what is ultimate bearing capacity? The maximum gross pressure that the soil can take without any shear failure. Here also, what is QU? What is the maximum load that I can apply on the pile safely to the soil? Okay. So now we need to find out the ultimate load carrying capacity. Sir, why we neglect friction and end bearing? I couldn't get. Arre Baba, you see, in the case of the end bearing pile, am I discussing anything regarding to the friction? No. Why you will get now? Why you will get now? Listen to me. So my point is to find out the ultimate load carrying capacity of the pipe. So now, determination of ultimate load carrying capacity of a pipe. So there are various methods. Static formulae, dynamic formulae, and pile load test. So these are the various methods or various formulas that we use in the case of the determination of the ultimate load carrying capacity. Now listen to me carefully. How come friction exists? Friction is not exist, friction developed. It's not I am not saying angle of internal friction. I'm not saying angle of internal friction. When the movement is there, the shearing is going to happen, right? That friction, I wait for that. I haven't completed it, right? So now, first thing, static formula. What happens in the case of the static formula? Listen to me carefully. Take the same pile. Now, you please observe. When a vertical load of Q is applied on the pile, when a vertical load Q is applied on the pile, means while I am driving, see, this is a final position, I'm telling you. So while I am driving, when a vertical pile, give me a minute. So now, when a vertical pile means when a vertical load is applied on the pile, slowly what happens due to that load, the pile will penetrate into the soil while we are doing the driving. Means or after the driving, now I am going to construct the structure. So while I am going to construct the structure, I have to construct the structure in a phase-wise manner. Yes or no? You cannot construct the total structure within a day, right? So first you are going to dig a means drive a pile or bore. You prefer whatever the installments you have placed the pile. Now I am going to construct the first floor. Due to that first floor, I am going to apply the vertical load. When a vertical load is applied on the pile, then slowly first what will happen? Friction will develop. Friction will develop due to the loading. First thing first, the pile will start to move downward. Yes or no? Or suddenly if you apply the load, the pile will start to move downward. When the pile starts to move downward, now it will get resisted by friction developed or friction or shear developed between the pile and soil. Point number one. When external load is applied on pile, it moves vertically downward. Okay. So up to that point, I hope you are clear. Now, what happens due to this? Due to this shear or friction develops between the pile and soil, known as skin friction. Okay. So first thing first, this is going to be develops on the soil, known as mobilized skin friction. Okay. Yes. Now, when okay, I can say it as known as mobilized skin friction. Okay. Now coming to the second point. What is the second point, sir? Look, now when the external load is going to be increases, when the vertical load is increasing, then the mobilized friction or the frictional resistance between the pile and soil increases over the entire surface area of the pile and reaches maximum, known as a skin frictional resistance. Second point, when the vertical load increases, what happens? Frictional resistance along surface area of pile. What is the meaning of surface area? Along the length of the pile, right? Surface area of pile increases, reaching maximum as skin frictional resistance QS. Okay. So point number 1 and 2, you please observe. When an external load is developed, so when the external load is going to be developed, then it moves vertically downward. Due to this, shear or friction develops between the pile and the soil. Okay, soil knows as a soil. No, means that is nothing but mobilized friction. And as you increase the vertical load slowly along the entire surface area of the pile, the skin friction increases and increases and increases and becomes maximum, known as QS. And now what is going to be happen? Now what is going to be happen? So up to this point, at this point, whatever the vertical load I applied is nothing but the QS. Yes or no? Whatever the vertical load I applied is nothing but the QS. Now, third point is when Q greater than QS, when vertical load increases further, when the vertical load increases further, which means Q is going to be greater than QS. Now, this is the point where the point bearing resistance is going to be developed. Now, from here onwards, the point bearing resistance is going to be developed. Now, when the vertical load increases further, Q greater than QS, then point bearing resistance mobilized. Then the point bearing resistance develops or mobilized. It's like up to that point, by the time it reaches to the bearing, so up to that point, whatever the skin friction developed, it was able to manage the load. And now when you are applying a vertical load more than the skin friction says to the soil below pile, array, I cannot take the load more than this, you please take. Now there comes the bearing capacity, means which is nothing but point bearing resistance is going to be developed. And once the point bearing resistance came, now whatever the soil below the pile tip, whatever the soil below the pile tip, it assured the soil above the pile tip, which means side soil. Side soil, now you take rest. I am here, you don't fear. I'll take the load. Then once the soil below the pile tip assist or gives the assurance to the side soil mass. Side soil mass, okay, I have reached my maximum. Now what I'll do is I'll share some load to you. Now, when vertical load increases, Q greater than QS, then point bearing resistance develops and skin friction reduces from maximum. Now skin friction is no more maximum. Whatever the skin friction, that is no more maximum. It's not going to be maximum. Okay. So when vertical load increases, Q is going to be greater than QS. Then point bearing resistance develop and skin friction reduces it maximum. Why? The skin friction believes the point bearing offers some resistance. And now the fourth one, if vertical load increases further, if vertical load increases further, then point bearing resistance becomes maximum. Resistance increases and becomes maximum. Okay, so this is how the ultimate load carrying capacity of a pile is going to be developed. So eventually, when I applied the vertical load, so the skin friction is going to be developed and the bearing resistance is also going to be developed. At the end, at that failure point, whatever the load, now the ultimate load carrying capacity of the pile depends upon both the bearing capacity, means the unit point bearing resistance, and skin friction. So this is how the static formula says. So first you tell me, do you think both the resistance are going to be developed at the same time? No. First skin friction develops and it becomes maximum, and then point bearing resistance develop. As a point bearing resistance increases, skin friction will take a little bit less. So now I can say when skin friction is maximum, bearing is not maximum. When end bearing is maximum, skin friction is not maximum. So eventually, what is the ultimate load is nothing but combination of bearing and skin friction. So now QU is equals to QB plus QS. QU is equals to QB plus QS. Okay. Yeah. So this QB, you please observe. I'm going to write it further. QU is equals to QB plus QS, right? FB into AB plus FS into AS. What is this FB, sir? What is this FB, sir? This FB is nothing but whatever this FB, this is nothing but bearing capacity of a soil at a pile tip. I was saying you what is a QB? That's a point bearing resistance from the soil at pile tip. What is a point bearing resistance is nothing but Are Baba, here there is a soil, na? This soil must be having some bearing capacity. So whatever the soil below the pile tip, whatever the soil below the pile tip, that soil bearing resistance only you have to cover. Whatever the soil below the pile tip, that soil bearing resistance only you have to take. So bearing resistance of the soil must at a tip, at pile tip. And what about the AB, sir? Okay, fine. Now you keep the AB aside. And what about FS? See, this is nothing but load now. The Q is nothing but a load. What is a load? Load is nothing but pressure into area or stress into area. So bearing capacity is a pressure that into area. What is this FS, sir? Fs is nothing but frictional resistance between pile and soil along length of pile. Along length of pile. Okay. What happened suddenly? Okay. So now does my voice is clear? Now does my voice is clear? Yeah. So now AB is nothing but area at the base of the pile tip, or area at the base. Sir, how to find out the area? See, whatever the bearing capacity is pile tip, which is nothing but load, is nothing but whatever the bearing capacity into area. What is that area? Are Baba, if the pile tip, if the pile is going to be a square pile or circular pile, if the pile is a circular pile, then AB is equals to pi by 4 d square. And if L is embedment length of pile, embedment length of pile, D is dia of circular pile. Dia of pile. Okay. So if it is nothing but a circle, then AB is nothing but pi by 4 d square. This is for circular pile. The most common shape that we take for the pile is nothing but circle pile. But if it is a square pile, then sir, You tell me if it is a square pile. If it is a square pile, come on. If it is a square pile, what is area? If D is a side, if it is a square pile, then it's going to be D square. D square, yes. So now, similarly, what is AS? AS is nothing but surface area of the pile. Surface area of the pile. You observe here carefully. You know that the skin friction is going to be developed along the surface area of the pile. Yes or no? Whatever the skin frictional resistance into surface area is nothing but skin friction, or whatever the frictional resistance into surface area is nothing but the skin friction. Okay. So what is surface area of the pile? Come on, tell me. The surface area is nothing but perimeter into length. What does it mean by surface area? Perimeter into length. Pi dl. And if it is a square, then 4 times of the side. So perimeter into length, that is nothing but 4 times of side, 4 dl. Yes. So basically, we generally go for mostly the circular pile only. Generally, we go for circular pile only. So you don't need to worry about the square pile. But if you do ask a square pile also, what happens? Areas will change. Now listen to me carefully. Listen to me carefully. This AB and AS depends upon what type of a pile you are going to install. And where L is nothing but embedment length of the pile, D is nothing but if it is a circle, dia, if it is a square, width. But FB and FS depends upon whom? The soil at the pile tip and the soil on the sides. So let's see that FB and FS. If the soil is clay soil, it is different. And if the soil is sand soil, it is different. Now, you see, this FB is nothing but bearing capacity of soil, which we have learnt in the previous chapter, which is nothing but ultimate bearing capacity. I am applying ultimate load, which means I have to take ultimate bearing capacity only. As I am asking you ultimate load carrying capacity, I have to apply ultimate bearing capacity. So now the FB is going to be as per Terzaghi. As per Terzaghi. You know that ultimate load carrying capacity, ultimate bearing capacity is nothing but here FB is equals to CNC. Come on, tell me. CNC plus gamma DNQ plus 0.5 gamma B and gamma. CNC plus gamma DNQ plus 0.5 gamma B and gamma. Okay. So now here, this is general equation. Don't apply any factors like circle or something like that. This is the general equation as per Terzaghi. This is an equation. As per Terzaghi, this is the equation. So give me a minute. One. No. So as per Terzaghi, this is the equation. Now, if you observe, we are discussing in a deep foundation, right? Yes. In deep foundation, the depth of the footing means the depth is going to be much larger than the width. What is the mean by width, sir? Width is nothing but diameter here. The width is nothing but the diameter. So we neglect the width effect. The width is nothing but diameter. R side. Okay. So in the case of the deep foundation, what we are going to do here is D much greater than B, which means neglect width effect. Okay. So eventually, what is the bearing capacity? CNC plus gamma D NQ. Okay. Now So if it is a case, how it is going to. Okay. So in the case of the deep foundation, see when NQ is equals to 1, in the case of the deep foundation, the CNC value is much larger than the gamma D. The CNC value is going to be much larger than the gamma D. Okay. So now in case, eventually the bearing capacity is nothing but C into NC. Now you please observe, finally, what is the equation? Okay. Fine. Listen to me carefully again. I'm repeating again. I'm repeating this again. See, as per Terzaghi, we know this is equation. As per Terzaghi, we know this is the equation. Okay. And you know, in the case of the deep foundation, the depth is going to be much larger than the width. So we neglect the width effect. When we neglect the width effect, then what else remaining is nothing but CNC plus gamma DN. CNC plus gamma DN. Okay. Now, what else remaining I have is nothing but FB, which is going to be CNC plus gamma D NQ. But in the case of the case, you know that NQ is equals to 1. Yes or no? In the case of the case phi 0 and NQ is nothing but bearing capacity factor, which is equals to 1. If NQ is equals to 1, what else left over is gamma D. See, compared to in deep foundations, compared to CNC, the gamma D value is going to be much lesser. Then I got to know the FB is equals to C into NC, where in the case of sands, means in the case of the clays. This is about the ultimate bearing capacity I was discussing about. Hope now my voice is clear. Sir, in deep foundations, what is D? In deep foundations, the D is nothing but L. So whatever the L is nothing but the D. Whatever the L is nothing but the capital D, which is nothing but the depth. Yes or no? Yes. Now, you please observe, as FB is equals to C into NC. Now, what is C? The C is nothing but cohesion of soil at pile tip. And that generally NC is equals to 9. Whatever the NC value you are going to use here, the NC is equals to 9. So it is no more 5.7. The NC is equals to 9. In the case of the deep foundations, we have to take NC is equals to 9. Okay, I hope you understood now. So but depth is more now, so how come we neglect that? Are Baba, depth is more, but compared to CNC, the C value, if it's a pure clay, it would be some 100 or 200. 100 into 9, 900. So compared to that gamma D, the value is going to be less. Okay. So this was mentioned by static formula. This was mentioned by the static formula. Eventually, the FB is equals to C into NC. Fine. Now, if you take sands, in the case of the sands, you know C is equals to 0. Yes. So now whatever this equation, in this equation, if C is equals to 0, then I can write FB is equals to sigma V into NQ. Sigma V into NQ. So what is this FB? The FB is nothing but the gamma d. I can take it as sigma v, right? The gamma d I can take it as a sigma v. So what is mean by sigma v? You please observe what is mean by gamma d. I am telling you whatever the vertical stress at a pile tip. So now if there is a water table, sir, what we have to do? The effective stress parameters I have to use. Simply, you know, as per Terzaghi, if there is a water table, below the water table, I have to use gamma as gamma dash. So what is this sigma v dash? The sigma v dash is nothing but vertical stress at pile tip. So now I got to know from this equation, I got to know what is the bearing capacity in the case of the clay soils and in the case of the sand soils. Hope you understood. This I derived from the Terzaghi only. Okay, but you see, I divided the total equation. I am not asking you to remember this equation. I am asking you, you split it. The load, there are two loads, bearing and skin friction. The bearing depends upon I don't know why there are too many interruptions happening. It is not getting. Okay. Yeah. Okay. Fine. So if you observe here, in the case of the sands, we just keep C is equals to 0, and whatever the C is 0, and this is nothing but gamma d. What is mean by gamma d? That's vertical stress. The gamma d is nothing but the vertical stress. So that vertical stress I am saying as a sigma v dash. Whatever the vertical stress, I am going to represent as a sigma v. But why you represent dash, sir? If water table is going to be present, you have to use effective stresses, right? If water table is going to be present, you have to use effective stresses. See, that's vertical stress, but I am going to use it as a sigma v dash. Now I hope you got it. Does my voice is clear? Does my voice is clear? Please let me know. Yeah. Okay, fine. So now this is about finding the ultimate bearing capacity. Now let's come to the frictional resistance. This frictional resistance is nothing but Fs is equals to Ca plus sigma h dash into tan delta. Don't ask me the derivation. Don't ask me the derivation because whatever the skin frictional resistance developed over here, it depends upon the number one. You see, array, this is a pile, this is a soil. Yes. And the attraction between the pile and the soil, which means the attraction between different metals is nothing but adhesion. So number one, whatever the skin friction developed here depends upon the adhesion. Number two, the lateral earth pressure also going to be there. There must be some lateral earth pressure also, right? Yes or no? While you are penetrating the pile, the lateral earth pressure will offer some resistance. So now this skin friction this skin friction is going to be depends upon number one, adhesion, number two, lateral earth pressure, where this CA, is nothing but adhesion between pile and soil. What is CA? Adhesion between the pile and soil. And this is going to be written as CA is equals to alpha into C bar. And what is this alpha, sir? Alpha is nothing but adhesion factor or shear mobilization factor. Adhesion factor or shear mobilization factor. Okay. So what is alpha? Alpha is nothing but adhesion factor or shear mobilization factor. See, so soil is saturated, then the skin friction is exist. Yes, but it will reduce eventually. You know, na? Why? Because now you see, now you are going to discuss about here. So adhesion factor or shear mobilization factor, and whatever the C bar is nothing but average cohesion along the length of pile. Along the length of pipe. Okay. So if you observe over here, now simply I can rewrite this equation. The Fs is equals to alpha into C bar plus sigma H bar into tan delta. Now, okay, fine. I have to explain these things also, right? Yeah. Now you observe. See, first thing first, what is CA? I told you CA is nothing but adhesion. But can I find out the adhesion? No, I cannot find out the adhesion. What I do is, throughout the length, whatever the cohesion is there, if it is a layered deposit, I have to take it as average cohesion. If it is a uniform deposit, the cohesion you can find it out. So whatever the C bar is nothing but average cohesion along the length of pipe. Sir, does this C and does this C and C bar are going to be same? Yes. When the soil is uniform, everywhere the cohesion is C only. But if the soil is not uniform, the cohesion at pile tip is different. The cohesion along the length of pile is different. Okay. And what about this sigma H bar, sir? The sigma H bar is nothing but average lateral earth pressure. Average lateral earth pressure. I hope you remember the lateral earth pressure concept, right? So if you do remember, the lateral earth pressure is nothing but some quotient of earth pressure into vertical stress. So the average lateral earth pressure is equals to K into average vertical stress. Give me a minute. Okay. So does my voice is clear to you? Does my voice is clear to you? Does my voice is clear? Yes, yes, yes. Okay, fine. So now, if you observe, see, while I was discussing, first I took the bearing capacity, and I have said that due to width effect neglect means deep foundations neglect the width effect. In this equation, you keep you neglect gamma d and q, that's going to be for clays, and you neglect the C value, that's going to be for the sands. And you know that the NQ value depends upon the phi value. NQ depends on angle of internal friction only. Okay. Now you see here, you know that sigma h is nothing but lateral earth pressure. But as I'm discussing along the length, means I have to take the total length. So I have to take average value. What is that average? Sigma h bar is nothing but average lateral earth pressure. Sigma h bar is equals to K into sigma V, where K is nothing but coefficient of earth pressure. Sir, what is this coefficient of earth pressure, sir? I'll tell you later. What is this coefficient of earth pressure? I'll tell you later. Okay. So here K value is a coefficient of earth pressure, and how we are going to take that value, I'll tell you later. Now, let's see, where sigma V bar is nothing but average vertical stress. Okay. So sigma h bar is equals to K into sigma V bar. And what is this delta, sir? The delta is nothing but angle friction or friction angle between pile and soil. Between pile and soil. And this delta depends on angle of internal friction. The delta is going to be depends on the angle of internal friction. Okay. So if delta, the friction angle between pile and soil, and delta depends upon the angle of internal friction. Now, if you observe sigma V bar, so everything is going to be written over here. What is CA? CA is nothing but alpha into C bar. And what is sigma H bar? Average lateral earth pressure. And what is delta? Friction angle between the pile and the soil. Now, if it is a clayey soil mass, if the soil is going to be clay, in the case of the clay, as I told you, the delta depends upon phi. So in the case of the clay, delta is equals to 0. As phi is equals to 0 degrees, we have to take delta is equals to 0. Sir, why you took delta 0, sir? I'll tell you, because delta is a function of y. Delta is equals to some value of phi. Delta can be phi, delta can be less than phi also. So that delta, when phi is equals to 0, delta is also going to be 0. If delta 0, then what is Fs? The Fs is nothing but alpha into C bar. The Fs is nothing but alpha into C bar. Okay. So now I hope you got this. And in the case of the sand, C bar is equals to 0, and which means Fs is equals to K into sigma V bar into tan delta. This is how you are going to get it done. See, first thing first, I divide the entire component, whatever the given equation, how to find out the ultimate bearing capacity. What I did is, I divided it into pressure and area. I don't have any problem with the area. I can find it out. That depends upon the pile. So pile area at base pi by 4 d square and pi dl surface area. And this FB and Fs depends upon the type of soil. So for that, for FB, I took Terzaghi and I modified. And for clays, it is CNC. For sands, sigma V dash into NQ. Now, in the case of the frictional resistance, For clays, it is going to be alpha into C bar, and for sands, it is going to be K into sigma V bar into tan delta. Note point over here. Number one, whatever the alpha, it is there for clays, right? So whatever the alpha for the soft clay, whatever the shear mobilization for the stiff clay is less than the alpha for the soft clay. There are some values given by the various scientists. For soft clay, what is alpha? For stiff clay, what is alpha? Generally, for soft clay, the alpha is around 0.7 to 0.8. For stiff clay, 0.3 to 0.4. But I am not asking you to remember those values because I'm not going to give that. So don't remember those values. Don't remember those values. Alpha stiff clay less than alpha soft clay. That's it. And the second point is, whatever the skin frictional resistance we develop in the case of the bored piles is more than the skin friction we develop in the friction piles. Whatever the skin friction developed in the case of the bored piles is more than the skin friction developed in the case of the friction pile. Okay. So why? Because why it is going to be bored pile has more friction than the driven pile. Why it has more friction in the case of the bored pile, sir? Sir, when you drive a pile, that's going to be having a smooth edges. Yes. But when you dig a borehole, the borehole is not going to be regular, right? This is a borehole. The borehole is not going to be regular. But for the driven pile, the face of the pile is smooth. So in the case of the borehole, there are many irregularities are there. Due to irregularities, more the irregularities, more the friction developed. Now, as I have discussed this as a total, now let's take separately one by one. For clay, how I am going to write the total. For sand, how I am going to write the total. Let's see that. If the soil is a clay, if the soil is a clay soil mass, so how I am going to do that? This is ultimate, right? So now, if this is ultimate load carrying capacity, let's say, listen to me, please. I'm going to take a clay soil. So let me take it as a layered deposit itself. Let me take it as a layered deposit. Okay. So now I'm going to take a clay soil mass. I'm going to take a clay soil mass. Okay. So let's say whatever the length I have here is, let's take it as L1, and whatever the length over here is, let's take it as L2. Okay. So now I am taking this as a soil mass, and let's say there is some hard strata somewhere over here. Or anyway, okay. So I want to find out the ultimate load carrying capacity of this pile. Okay. And let's say the soil one is going to be C1 and it is going to be C2. It is going to be C2. Okay. Now I want to find out the ultimate load carrying capacity. The ultimate load taken by the pile depends upon the point bearing resistance plus skin frictional resistance. This point bearing resistance depends upon the bearing capacity into area at base, skin frictional resistance into AS. Now, can you please tell me, in the case of the clays, what is FB? So QU is equals to, I can write directly over here. FB is equals to CNC. FB is equals to CNC. C. Yes. No. FB. Why we are getting these many problems today? I don't know. Not getting. This is very interesting topic actually. Now, does my voice is clear? Does my voice is clear? So now, if you observe, you know that for clay, FB is equals to CNC. Already I have find it out. FB is equals to CNC. And what is FS? And what is C value here? You know the C is nothing but cohesion at the pile tip, right? I have clearly mentioned that. So what is C value? The C value is nothing but cohesion at the pile tip. So here the C is nothing but C2. Yes. And what what about FS? Alpha into C bar. This alpha value is C2. So I have to take it as a weighted average. I have to take it as weighted average. What to do? Even I kept the rotor. Okay, let me turn off the video. Now you tell me, please. So I will go. I mean, I'm logging off and I log in again. Yes. So now I'm switching off my video. So please let me know. Now, okay, fine. I'll remove this. Yes. So now does my voice is clear, please? So if it is any problem, please let me know immediately. Okay. Now let's see, you know this. And in the case of the clay, the bearing capacity is nothing but C into NC, where NC is equals to 9. Yes. Okay. So that is the reason why I have given you. That is the reason why I have given you. See, I have already explained you. So now immediately in your mind, what is the bearing capacity of the clay? CNC. And what is that C? C is nothing but cohesion at pile tip. Yes. So now if you see, what is the cohesion at the pile tip here? The cohesion at the pile tip is nothing but C is equals to C2. C is equals to C2. Yes or no? Now, what about Fs? Just now we mentioned that the Fs is nothing but alpha into C bar. Okay. The C bar alpha in the given question, they will mention alpha C bar. Alpha they will be mentioned. But now I have to take the C bar. What is the C bar? The C bar is nothing but average cohesion along the length of the pipe. But are you going to take the direct average? Are you going to take the direct average C1 plus C2 by 2? No, because up to certain length L1, the cohesion is C1. And in the length L2, the cohesion is C2. So you have to take the weighted average. And what is this weighted average? The C bar, the weighted average is nothing but C1 L1 plus C2 L2 by total length L1 plus L2. Weighted average. What is this? Weighted average. In simply, the centroid formula is there, right? Whatever the weighted average formula, you have to take it. So no matter how many layers they are going to be give you, that cohesion into that layer, that cohesion into that layer. So C1 L1 plus C2 L2 by L1 plus L2. And if this is the case, finally, what is the ultimate bearing capacity? The ultimate bearing capacity is nothing but CNC into AB plus alpha into C bar into AS. That's it. You tell me now, is it easy to remember by splitting or is it easy to remember by means of the total? See, I'm not asking you to remember the whole formula. If you do remember, then somewhere you will miss it. That is the reason why I'm splitting first bearing capacity and skin friction resistance. Hope you understood this now. If the soil is uniform, then you have to take C bar is equals to C. If soil is uniform, then C bar is equals to C. If the soil is going to be uniform, then the C bar is equals to C value. Okay. So you have to take these values. No. Hope you understood. So that's about the clay soil. That's about the clay soil. Okay. Now, if you observe, let's come to the sand. If you have understood this, let's come to the sand. In the case of the sand, okay. So let's take this is nothing but a sand, my dear. The total soil is nothing but a sandy soil. And you know the length of the pile is nothing but L. The length of the pile is nothing but L. Okay. Again, fine. Let's write down the equation, please. First, what is the ultimate load carrying capacity? Again, QB plus QS. And that is going to be QB is nothing but FBAB plus FSAS. Okay. Now, what is this FB, sir? You know that in the case of the sands, the bearing capacity is simply, I told you, sigma V dash into NQ. Yes. If you forget about that, from the case of the Terzaghi series, there are three effects: cohesion effect, width effect, depth effect. Width effect you neglect. If it is a sand, cohesion effect also neglect. Then what else remaining? Depth effect, which is nothing but sigma V dash into NQ. Now the point is this sigma V dash. Now, from the field observations, it was said that from field observations, from field observations, what is happening over here is vertical stress sigma V dash increases up to certain depth DC and then varies linearly due to arching effect. What is that? Due to arching effect. Okay. So the vertical stress, if you observe, the vertical stress from the field observations, the vertical stress increases up to certain depth and then varies linearly. And then remains constant. Remain constant due to arching effect. So what is mean by arching effect? So wait for that. First, let me write down that draw. Means let me draw that. So if you see, what is the meaning of this one is, if you draw the stress distribution, vertical stress distribution. Okay, the meaning here is from the field observations, the vertical stress increases up to certain depth. What is that depth? That depth is DC. So this vertical stress is going to be increases up to certain depth. Let's take the depth as a DC. And then it is going to be remain constant. What is the meaning of constant? What is the meaning of constant? The meaning of constant is this one. Okay. So this is how the vertical stress is going to be varies. And whatever the depth up to which it is going to be varies, whatever the depth up to which it is going to be varies is nothing but, let's take that depth as DC. Whatever this depth, we call it as DC. So the what is nothing but DC, sir? The DC is known as a critical length of pipe. What is DC? The DC is nothing but critical length of the pipe. Okay. So now coming to over here, FB is equals to sigma V dash into NQ. FB is equals to sigma V dash into NQ. Okay. Now let me take this one again. If I can write over here. So FB is equals to sigma V dash into NQ. What is a sigma V dash? The sigma V dash is nothing but vertical stress. Yes. So as it is going to be varies up to linearly. Now, if there is a water table, then sigma V dash, what is the value over here? Gamma dash into DC. Yes or no? And here also it is going to be gamma dash into DC. Here also it is going to be gamma dash into DC. Okay. So sigma V dash is equals to gamma dash into DC. Sigma V dash is equals to gamma dash into DC when the length of the pile is more than when the length of the pile is no more than the DC. And sigma V dash is equals to gamma dash into L when the length is less than the DC. Sir, what is this DC? The DC is nothing but critical length of the pile. The DC is nothing but critical length of the pile. Okay. So in the case of the sand, what happens is the vertical stress is going to be increases up to certain length known as critical length, and then it remains constant. So why, sir? Why? It is due to arching effect. So now what is mean by arching effect? First, this critical length is equals to 15 times of dia of pile in the case of the loose sand. In the case of the loose sand, and this DC is equals to 20 times of the dia of the pile in the case of the dense sand. In the case of the dense sand. Okay. So DC critical length of pile. Now, what is mean by arching effect, sir? what is mean by arching effect? Arching effect is nothing but transferring of the load between two bodies having a different stiffness. Transferring of the load or load transfer between bodies of different stiffness. So I hope you know the meaning of stiffness. Stiffness is nothing but resistance to deformation. Stiffness or consistency, both are same. So stiffness is nothing but resistance to deformation. Okay. So if the resistance to deformation, now what is mean by arching effect is load transfer between bodies of different stiffness. So then why this arching effect comes into existence over here, sir? The arching effect comes into existence over here. Why? Because if you observe, why? Because you see up to this DC, this is nothing but a pile and this is nothing but a soil. Yes, the pile and the soil has a different stiffness up to the DC. Listen to me carefully. Up to this DC, the pile has a more stiffness than the soil. So pile and soil has a different stiffnesses. Pile has a more stiffness than the soil, so that the load is going to be transferred from the pile to the soil. So that the load is going to be transferred from the pile to the soil, then the vertical stress is going to be increases. But if you see in the remaining portion, whatever the remaining portion L minus DC, in this zone, what happened is beneath that depth DC, the stiffness of the soil and the pile are almost same. The stiffness of the soil and the pile are almost same. Okay, because you know that if you go deeper and deeper, soil becomes denser and denser. Yes. If you go deeper and deeper, soil becomes denser and denser. So beyond DC depth, below this DC depth, the pile and the soil attain almost similar stiffness or same stiffness. When the is same, then there is what arching effect. The arching effect is nothing but again. Too much of what can I do? Give me a minute, please. I'm sorry to say this. Because due to this continuous lagging, I cannot continue. Okay. So what I can do over here is I'll stop here. Means I'll share the class up to the class, but for the science, because after some time again, people now does my voice is clear? Okay, fine. Okay, fine. So now you please observe. So the arching effect is nothing but, listen to me carefully again. So the arching effect is nothing but, then the arching effect is nothing but, you see up to the depth DC, the stiffness of the pile and the soil are different, so that the load will transfer, but beyond this depth DC, the soil attained some dense state. Due to that, what happens is the stiffness of the pile and soil both are same. So beyond DC, the vertical stress remains same. That is the meaning of arching effect. Okay. Yes. Now, if you observe, that's about the FB value. That's about the FB. Okay. So you know how to find out the FB. What is FB? FB is nothing but vertical stress at pile tip. What is FB? What is FB? FB is nothing but vertical stress, means what is sigma V dash? Vertical stress at pile tip. Now coming to the FS. What is FS? What is FS? So in the case of the sand, the FS is nothing but, what is FS? FS is nothing but K into sigma V dash into tan delta. K into sigma V dash into tan delta. Okay, and I have one more value over here. You please observe. There is a range of the FB value. The range of the FB value is, this FB should be or should not be more than 11,000 kilopascals in the case of normal silica sand. That's the range. It should not go beyond 11,000 kilopascals. Or I can write should be less than or equals to. Similarly, the FB should be less than or equals to 5,000 kilopascals in the case of calcareous sand. Which is nothing but sand mixed with lime. Calcareous sand, which is nothing but sand mixed with lime. Okay, so these are the ranges. See, in examination, especially in ESE, they might be asking this. In ESE, they might be asking this, the ranges also. So the sand is going to be a little bit complex. You see the clay. The clay is very simple, CNC and alpha C dash. But for the sand, you have to be very careful here. So if they don't give you the DC, in examination, listen to me. In examination, if they don't mention DC, you just take DC is equals to L. In examination, if they don't mention DC, you just simply take L is equals to DC. But generally they will mention. Okay. Now coming to the FS, where K is equals to sigma V dash into tan delta. Now, you know this sigma V dash. First, let's see this sigma V dash. Let's see this sigma V dash. And if you observe here, the sigma V dash is nothing but average vertical stress, right? Average vertical stress. Does my voice is clear for you? Yes, right? Yeah. Now, so average vertical stress. Now, you see up to DC, what is the average vertical stress? Come and tell me. Up to DC, what is the average vertical stress? Up to DC, the average is on top, it is going to be 0. On top, it is going to be 0. And up to DC, the average is going to be 0 plus gamma dash into DC by 2. So here the average is 0 plus gamma dash into DC by 2 because that's linear. And in the L minus DC, it is uniform. Na? The uniform means average is gamma dash into DC. So again, I have to take weighted average because up to DC, it is a linear variation. Beyond DC, it is uniform. So now what I'll do is the sigma V dash is equals to up to DC, it is going to be 0 plus gamma dash into DC by 2. Into DC plus plus, so 0 plus gamma dash into dc by 2 into dc plus whatever the, see you here, you see here, what is the average over here? The average here is gamma dash into dc only. Why, sir? Sir, everywhere the uniform, na? So gamma dash into dc into L minus dc by, what is the total length? The total length is L. This is how you are going to find out the average. Again, here also it is a weighted average only. So this is L. Hope you understood. So once you draw the pressure distribution, you will get to know everything. Okay. So this is nothing but sigma v dash. This is nothing but sigma v dash. But now there comes the k value and tan delta value. There, here we have some differences. The differences are, if it is a driven piles, first for bored pile in sand, in the case of the bored piles in sand, you see the k value varies from 0.3 to 0.75. The k value varies from 0.3 to 0.75 with a mean of 0.5. With a mean of 0.5. So the k value is going to be varies from 0.3 to 0.75. Generally, we are going to measure by means of k minus sine phi by dm. Generally, we measure by means of k is equals to 1 minus sine phi. Whatever the equation is there, right? K is equals to 1 minus sine phi. And that k value is going to be varies 0.3 to 0.75. 0.3 to 0.75. These are all the values by means of the observations. These are all the values by means of the observations. So approximately the k value, the coefficient of earth pressure here at rest, 1 minus sine phi, k is equals to 0.3 to 0.75 and delta is equals to 5. Where in the case of the bored piles, keep that in your mind. This is in the case of the bored pile. So if I install the pile by means of boring, then the k value is equals to 1 minus sine phi and delta is equals to 5. This is the one reason why I took in case delta is equals to 0, because phi is equals to 0. But sir, what about for the driven, sir? So for driven piles, as per Brom, Brom is a scientist who has given these values. For the driven piles, he was given in Brom. He gave the values on 1966 for various, because the driven pile is made up of, yes, you please observe. In the case of the driven piles, because while you are going to drive, I told you in the case of driven piles, either concrete or steel or timber, etc., whatever the piles that you are going to drive. In bored piles, you don't drive anything. In bored piles, you just dig a borehole. In bored piles, you just dig a borehole. Okay. So generally for bored piles, if I give you the pile as a bored pile, you have to take delta as pi. But if I give you the pile as a driven pile, if it is a steel, if the pile is made up of a steel, then delta is equals to 20 degrees and k value 0.5 to 0.5 loose sand, 1 is for the dense sand. If I give you the concrete, then delta is equals to 0.75 for concrete, delta is 0.755 and k value is 1 for the loose sand and 2 for the dense sand. Generally, for driven piles, k value ranges from 1 to 3. So these questions can be asked in the case of the ESE. These questions can be asked in the case of the ESE. So please observe here carefully. Forget, sir, should I have to remember all these things for gate? You don't need to worry about for gate. For gate, They will clearly mention. In the case of the gate, they won't take any assumption. In the case of gate, they will be clearly mentioned. And if the case of the driven, mostly the questions will occur from concrete. In the case of concrete, I have to take delta as 0.755. 0.755. Okay. So now the note point is note point. If nothing is mentioned about DC, take L is equals to DC. That's it. This is the total variation, and you know what is mean by FB, and you know what is mean by FS. So I hope you got this. I mean, once we start solving a problem, then you will feel much easier. Sir, how he obtained these values? By means of experiments only. So whatever the experimental studies by Brom, he has given these values. Okay, but if it is in the case of the bored piles, you don't need to worry. You just take delta is equals to 5. You just take delta is equals to 5. Okay, so hope you understood. If I solve a question based upon this, then it will be much easier for you. And see, today actually we lost more time, and I am going a little bit slow also because I don't know when the lagging is coming, and I am repeating the same concept again and again. So tomorrow I am trying to take the class from 4 to 9 p.m. Is it fine? See, what I'll do is keep 2 to 9, because see, I can take 2 to 9 rates, not a problem, but there are classroom, college goers, so I have to keep those in mind. So what is that? Tomorrow is Thursday, right? Yeah. So Thursday. See, this is our timetable that we are going to follow. Thursday, 4 to 9 p.m. and Friday also 4 to 9 p.m. but Saturday 2:30 to 9 p.m. So this is the timings. For all batches. Whatever the batch it is there, for all the batches, this is going to be the timing. And for ESE only, the extra syllabus. For ESE, the extra syllabus. So that is like on Friday. Yeah. So 9:30 to 12 p.m. 9:30 a.m. to 12:30 p.m. And Saturday also the same timings. This is for the ESE only. Okay. So I hope these timings means if I can push, I can push, but I have to keep the remaining people also in my mind. So that is the reason why I was not taking from 2 to 9 for all the batches. But anyways, you have to come on Saturday. Saturday from 2:30 to 9 p.m. and Sunday holiday. So Sunday holiday, that sounds so good. And whoever are having a classes on 6th onwards, you can travel during Sunday or Monday. You can join whatever the respective hostels over here. So you can do whatever you want on those 1 or 2 days. Okay. So this is what so by this time I can definitely finish the syllabus. So the syllabus will be definitely completed. But as we have taken a lot of time today, so okay, now let's see some questions. For the first, I have to crop right. What's the time now? 8 o'clock. Okay. So now you see this question. Question number 1. A bored concrete pile 30 centimeters in diameter. So whatever the bored pile I have given, so I don't need to worry about anything. Whatever the bored concrete pile, whose diameter is going to be 30 centimeters, 0.3 meters. Now listen to me carefully. So 0.3 meters. And in diameter, so 6.5 meters length passes through stiff fissured clay. So soil is nothing but clay soil. Is subjected to seasonal shrinkage and swelling. Is subjected to seasonal shrinkage and swelling. See, listen to me this point. See, it is said that the soil is subjected to seasonal swelling and shrinkage up to a depth of 1.5 meter. As the soil subjected to swelling and shrinkage up to a depth of 1.5 meter, I have to neglect that 1.5 meter, which means in that 1.5 meter, soil will not be in contact with the pile. So if I draw the pile, so this is nothing but a pile. Ground level. Okay. Now, in this case, what it is mentioning is in the top 1.5 meter, soil is undergoing swelling and shrinkage. So in the top 1.5 meter, the soil undergoes swelling and shrinkage, which means the top 1.5 meter is not responsible for any skin friction at all. The top 1.5 meters is not going to be give any resistance. So now can you please tell me what is the length? The length I should take here is, so that length, the length is going to be 6 minus 1.5, which is equals to 4.5 meter. Okay. See, whenever they use the seasonal shrinkage and swelling, you just remove that weight. And if you observe, then neglect the top 1.5 meters of soil. I have already given you. Neglect the top 1.5 meters of soil. And this is a clay soil. The average undrained strength of clay. You know the meaning of undrained strength is nothing but cohesion. The average undrained strength of clay up to the pile tip. So what is average undrained cohesion? Average is 50 up to the pile tip, which is nothing but 50 kilopascals. And it is going to be 100 kilopascals below the pile tip. Below the pile tip, it is going to be C value, 100 kilopascals. I told you clearly what is C. The C represents the C represents the, it is 6.5, sorry, 6.5, right? 6.5 minus 1.5, this is going to be 5 meters. Okay. You know that the average means C bar and the cohesion at the pile tip is 100. So now, if the assuming adhesion factor is 0.3, what is the ultimate load? I am asking you the ultimate load. However, in the case of clay, don't you know the ultimate load? Directly you can write it, right? So what is ultimate load? The ultimate load is nothing but base resistance, point base resistance plus skin friction resistance. So which is nothing but, I can write the QU is equals to, what is FB? FB is nothing but CNC into area, as it is a circle pile, pi by 4 d square, alpha into C bar into pi dl. You know that I asked you to remember the 4 things separately. You remember FB separately, FS separately, AB separately, A separately. Simply substituting rate. And what is NC value? You know, if they do mention or don't mention, you know NC value. The ultimate load is nothing but C, 100 into 9 into pi by 4 d square, which is nothing but 0.3 square, plus alpha 0.3 into C bar, 50 into pi into d value, 0.3 into L, which is nothing but 5 meters. Come on, tell me the ultimate load. Tell me the ultimate load. The ultimate load is 134.30. Is it? Is it 134.30 kilonewtons or anything else? So 134.30 kilonewtons. I hope you got these values. I don't think that much less. Is it so? 9 into pi by 4 into 0.3 square into 900. Array. Who said this value there? This is 643, my dear. What is this value? For solving, you're getting that's 643.24. You see the C value, it's not 10, it's 100. The answer is 643 point. Answer is 134. Why you are getting 134? You please check it once again. Pi by 4 into d square, 0.3 square into. Okay. Maybe I have done wrong. Okay. Yes. I'm sorry. Sorry, the answer is 134 only. 134.30 kilonewtons. That's it. I'm sorry. Now, this is nothing but a question number one. This is very simple, right? It's simply, I just have to apply this. Now you see the second question. You see this question? A lot of people were asking me, sir, how do we know the soil is a layered deposit? How we get the values, something like that. This is nothing but soil exploration data, or we can say it as a borehole data. Whatever the soil sample we collected from the borehole at regular intervals, after doing the test, we got to know these values. Now I am asking you, estimate the safe load carrying capacity. Remember, safe load is nothing but ultimate load by factor of safety. I should write here. Whatever the safe load here. So the safe load should be ultimate. I don't have any space. Okay, fine. Ultimate by factor of safety. The safe load in the case of here is nothing but ultimate load by factor of safety. Now, again, it's a single bored pile, boring pile. So boring, which is going to be dia of 500 mm, which is nothing but 0.5 meter, and length of 20 meters, alpha 0.4, factor of safety is given as 2.5. Now, you please draw the figure. You please draw the figure. So now first you see, in the first 0 to 5 meters, the soil is loose fill. And what is undrained shear strength? See, the soil is clay, right? What is the meaning of undrained shear strength? Cu. So in the first 5 meters, the soil is a loose fill. In the first 5 meters, the soil is a loose fill. Okay. Now, so in the first 5 meters, the soil is a loose fill. So this is first 5 meters. Loose fill whose cohesion is going to be 50. Okay. In the next 5 to 10 meters, then C2 cohesion is going to be 70. Cohesion is going to be 70. And next in the 10 to 15 meters, in the next 10 to 15 meters. Okay. C3 is equals to 100. C3 is equals to 100. Next 15 to 30 meters up to here. So for the next 15 meters, the C4 value is 200 kilopascals. Okay, so this is what mentioned. Now, if you observe, what is the length of the pile we have? 20 meters only, right? So our analysis is up to the pile tip only. Yes. So now whatever this value is nothing but just 5 meters only, because what is the total length of the pile? The total length of the pile is 20 only. So now I want to find out the factor of, means I want to find out the safe load. First you find out the ultimate load. What is the difference between previous question and this question? In the previous question, I gave you directly average and I gave you C value. In this question, I have given you the stratified deposits. You have to find out the average cohesion and what is the cohesion at the pile tip. See, at the pile tip, what is the cohesion? C is equals to C4 is equals to 200. Now, you see, what is ultimate load? Ultimate is nothing but FBAB plus FSAS. As you know clearly, in the case of the clays, CNC into pi by 4 d square, alpha into C bar into pi dl. Yes? Okay, fine. Now, if you see, I have given you alpha value 0.4. Yes. So alpha is there, pi is there, d is there, l is there, d is there, nc is there, c is there. What we require is only C bar. How to find out the C bar? You know that C bar is nothing but average. So what is the average? C1 into 5 meters plus C2 into 5 meters, because everywhere it is going to be 5 meters, 5 meters, 5 meters only. C3 into 5 meters. C4 into, should I take 5 meters or 15 meters? Should I take 5 meters or 15 meters? I have to take 5 meters because I want the average cohesion along the length. So up to 20 meters only I want. Into 5 by total length, which is going to be 20. Simply it is going to be C1 plus C2 plus C3 plus C4 by 4. You please observe. Because I'll take the 5 common. If I take 5 outside, 5 by 20, which is going to be 1 by 4. Don't think it is applicable for everywhere. Here the lengths are common, no? As they are length common lengths, so I can take this one, which is going to be C bar is equals to, what is the value? 50 plus 70 plus 100 plus 200 by 4. What is the C bar value? Which comes as 105. 105 kilopascals. So the ultimate load carrying capacity is C value 200 into 9 into pi by 4 into d square 0.5 square plus alpha. What is alpha given? Alpha is 0.4 into C bar 105 into pi into d value 0.5 into, what is L value total length? 20 meters. Find out the ultimate load carrying capacity. So after solving, you'll be getting as 1672.89, or in fact rounded to 2 decimals, 90 kilonewtons. But what is safe? 1672.90. This is safe by 2.5. Which comes as 669.16 kilonewtons. 669.16 kilonewtons. Okay. So this is a safe load. Now you tell me, still do you feel it is difficult? See, I know that it is lengthy. I know it is lengthy, but is it difficult? Tell me. After all the discussion I have made, after all these many times I repeated these values. So now you please tell me, is it difficult? Okay. Now, let's see the last question for today. A 12-meter long, 300 mm diameter concrete pile. So now you see this is a long pile, 12 meters. And see, I'm writing the I'm writing the data while I'm reading the question itself. What is the diameter? 0.3 meter. and the given pile is concrete pile. Okay, so immediately in your mind it should come. Okay, it is a, and where you are going to deposit in the sand. Okay, so now immediately in our mind we should get to know that okay, soil is sand. As a soil is sand, and the concrete pile is nothing but a driven pile, na? If it is a driven pile, we know that delta is equals to 0.75 times of pi. We know that delta is equals to 0.75 times of pi, and already I have mentioned those values, right? So please observe, I gave you the K value. If it is a dense sand, what is the K value? 2 also. If it is a dense sand, what is the K value? 2. But already they have given the K value for the dense sand is 2. Because the given soil is dense sand. So now I hope you understood whatever the data. So that is the reason why I peculiarly mentioned those values. So in the case of sands only, we need to worry about this. In the case of sands, for bored piles, the K value is different, delta different. For driven piles, the values are going to be different. Okay. Now, if you solve, K is equals to 2. Okay. Now, the water table is very much down and not likely to rise in the future. So if I draw the pile, let me draw the pile. And apart from this, what is the other data? Using NQ is mentioned as 137. Gamma is given as 18 kilonewton per meter cube. And factor of safety as 2.5, and assume the critical length of pile is 15 times of diameter. I already told you in the case of gauge, means this is a previous ESC question, mains question, but if they give you in gate question also, they will give you the relevant data, whatever the data that is there, that will be definitely given, because the people knows that there is an ambiguity. If they don't mention anything, that's a different issue. So 15 into, there was one previous gate question, my dear. Listen to me. There was one previous gate question. There they did not mention the critical length of pile. When they did not mention the critical length of pile, you have to take the length of the pile itself as a critical length. So 15 into diameter 0.3, which is going to be 4.5 meters. So now what I am asking you is, what is I am asking you? Safe load carrying capacity. For the safe load carrying capacity, first we need to find out the ultimate load. What is ultimate load? FBAB plus FSAS. First, let me write down. In the case of sand, FB, simply the depth effect, sigma V bar B dash into NQ into AB, plus what is FS? Skin friction, na? Which is nothing but K into sigma V bar into tan delta into AS. Okay, fine. So now you see what are the things I have. I have NQ with me. I can find out area. I have delta with me. I have K value with me. Now what we require is sigma V dash and sigma V bar. How to find out that sigma V dash and sigma V bar? Now I have to draw the pressure distribution, and you know it clearly. The pressure is going to be increases linearly up to DC. Up to DC means 4.5 meters only. And beyond that, it is going to be constant. So whatever this is nothing but 4.5 meters, my dear. What is the total length of the pile? 12 meters. And what else remaining? Remaining is 12 minus 4.5. 12 minus 4.5. What is 12 minus 4.5? 7.5 meters. Can you please tell me what is this value over here? So I have given gamma into 4.5. Here also gamma into 4.5. Yes or no? Yes or no? So now what is a sigma V dash? What is sigma V dash? So sigma V dash is nothing but gamma into 4.5. Why? the length of the pile is more than the DC. Now 18 into 4.5. Yes, 18 into 4.5, how much? Which comes as 81 kilopascals. So now at this point, this is 81. At this point also, this is going to be 81. Now, up to 4.5 meters, the variation is linear. In the 7.5 meters, it is going to be uniform. So next, I need to find out the what is the average vertical stress. Average vertical stress is nothing but weighted average, na? As it's linear, I can directly say half. Linear variation, top plus bottom by 2, 81 by 2. So 0 plus 81 by 2 into 4.5 up to 4.5 plus in the remaining 7.5, it's a uniform. 81 into 7.5 by total length is 12 meters. So what is the average vertical stress? Come on, tell me. Yeah, generally for DC it should be 20 times of D, but they have mentioned as a 15 times. So as they have mentioned now, so I cannot do anything. As they have mentioned directly, so I cannot do anything. Okay, give me a minute. So you solve it. By 12. So answer this is comes as 65.8125 kilopascals, or I can take it as 61.85 kilopascals. Okay. So sigma V bar 65.81 kilopascals. Now you simply substitute everything. So QU is equals to, I have 81. And what is NQ value? The NQ value is 137. And what is AB? Pi by 4 D square. What is the D value? The D value is going to be 0.3 meter. Plus K value given as a 2 into sigma V dash V bar 65.81 into, and delta. What is delta? Delta is 0.755. So which means 0.75 into 40 degrees. That comes as 30 degrees. Tan 30 degrees into pi into D value. What is D value? The D value is again 0.3 into L 12. So the ultimate load carrying capacity. Come on, tell me what is this value? 1643.87 kilonewtons. And what is the safe? 1643.87 by the factor of safety is how much? The factor of safety is 2.5. 1643.87 by 2.5. 657.55. Actually, in the material, the solution would be wrong. In material, it's around, I think, some 866 something like would be there. But in material, whatever the value it is there, it's wrong. So the correct answer is 657.55. In material, whatever the value, solution given for delta is equals to 5. So delta is 5 only for whom? Bored piles. Keep that in your mind. Delta is equals to 5 only for bored pile. If it is a concrete pile, delta is equals to 0.75 times of pi. The FB value extending 11,000. Are Baba, whatever the value we got itself is 1640. How come it is extending 11,000? How you got 111,097 pi by 4 into 0.3 square into 137 into 81. That is 784.4. The FB value is 784.4. Okay. So you see the equation is this much only, but if you split this equation, there comes the beauty. It's not about I'm telling you again and 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 again. Do not remember this as a single formula. You please split it. What is FB? What if FS? So if you split it, it would be much more easier for you. It's a civil service mains question, my dear. It's a main. So whatever this value, this is a mains question. Yes, in civil service also GATE, I mean, geotech would be there, means civil engineering would be there as an optional paper. In civil services, so there is no one optional paper would be there. Apart from the general studies, one optional paper should be taken. If you are writing civil services and you can opt your engineering background, so you can go for the civil engineering also. There's one paper would be the optional paper. Okay. So that's all for today. Actually, a lot of disturbances came due to this. but hope you got the concept behind this. I have written everything. Yeah. So that's all for today, and I'll stop the session for now. And we'll meet tomorrow. So as I told you that tomorrow timings. This is the timings. These are the class timings. Okay. So don't forget about this. Yeah. I'll meet tomorrow. Good night. I'm not going to take any doubt clearing session also. Okay.